Hello everyone, welcome to Vedantu Malayalam channel. I'm Sana Khan, your maths master teacher from Vedantu. And we are here with chapter number 1 of plus 2 mathematics, right? So yesterday we started this chapter. In lecture number 1, we saw the introduction of this chapter, right? Today is basically lecture number 2, where we will be learning about the different types of relations that we have and how do we identify them. Okay, so basically from this topic they are going to ask questions, they are going to give you examples, scenarios, where they will basically ask that do you think that it is a reflexive relation, do you think that it is transitive relation, those kind of questions basically. Okay, so yeah, it's going to be an interesting class because types of relations are quite interesting. If you observe them, there is a one single pattern. If you understand it once, you can solve all the questions. Okay. So yeah, get set, ready. We will be having so much of fun learning every concept with every minute detail so that you will never have any doubt and practicing as many questions as you want. All right. Now, before we start on, I would really like to welcome all the 2023-24 batch new students to Vedantu Malayalam channel. Thank you for choosing us. We guarantee you that for your physics, chemistry, maths and biology, this channel is going to be one-stop solution for every kind of preparation, be it your board preparation, competitive exam preparation, understanding the concepts, doing fun quizzes, everything will be catered here itself. All right. Now, I hope you guys know about me too. If not, here's a little introduction about me. My name is Sana Khan, okay? And I have been teaching maths from past 6 years now. And I am basically a software engineer. I graduated from NIT Raipur. Yes, I did clear JEE mains and advance, and I studied BTech in information technology. But doing my engineering itself, I realized my passion for teaching, and I'm here teaching mathematics to you guys. Okay, so yeah, I hope you'll have fun with me. And let's start today's class. First of all, a recap for all of you who have not seen lecture number 1. Please watch it, because in lecture number 1, we completed a lot of topics. We studied about sets, their representation, cardinality of sets, what are the different types of relations, domain and range of relations, and cardinality of relations too. So we completed all these topics in lecture number 1. They are the basic of this chapter. So if you have not studied those topics, of course, the future topics will get difficult for you, right? So please go through them. Okay, all right. Now, what are we going to learn today? Let's see. So basically this chapter has been divided into 5 lectures. Lecture number 1 already completed. Lecture number 2 we are going to learn about types of relations. Then these lectures are coming in the coming days. So types of function will be there on Monday. This will be on Tuesday and this will be on Wednesday. Coming Monday, Tuesday, Wednesday we'll complete the chapter. Lecture number 3, 4 and 5. Alright. Okay, so are we ready to start? Give me a high five quickly in the chat box and we will begin. So, starting with the different types of trivial relations that we have. Now, what do we understand by trivial relations? Relations which are part of every Cartesian product. Can you guess who are they? Well, they are basically empty relations, universal relations and identity relation. These relations are part of every Cartesian product. Let's see how. Now, what is an empty relation? From the name itself, you can clearly understand that it has nothing. It is empty, right? So, a set which basically is not mapped to any element is a null set or empty set. It is denoted by the symbol phi. Now, can you guess an example? Well, the very simple example will be, suppose I have a set A set A has 4 elements, 1, 2, 3, 4. Okay, I am defining a relation from A to A. I am defining a relation from set A to A such that it contains element X, such that X is what? Let's say X belongs to, no, sorry. Our relation contains ordered pair AB. What kind of ordered pair AB? Where A plus B is equal to 11. Okay. And as we know, A and B both belong to set A. So, out of 1, 2, 3, 4, can you tell me any number whose sum is 11? Is it possible? 1 plus 4 is 11? No. 3 plus 4 is 11? Nope. 3 plus 2 is 11? Nope. There is no number which you can add and get 11, right? So basically what will this relation has? This relation has nothing. It will have no elements, no ordered pair, because no two elements can add up to form 11. That's why it is an empty relation, right? Hi Kartika, welcome. Okay, similarly, what do you understand by universal relation? Hi Anirudh, I was thinking that how come Anirudh is not here? we just started, okay. Now, next is what is universal relation. So, from the name itself, it's like a whole universe. Universe has what? Universe has everything, right? So, here also, suppose you have a set A and we define a relation from A to A, then basically, if the relation has all the elements of A cross A, then it is a universal relation. How is that possible? Again, let's take the example that my set A has 4 elements, 1, 2, 3, 4. Now, A cross A will have all the ordered pair, 1 with 4, 2 with 4, 3 with 4, 1 with 2, 3 with 1, and so on. All the ordered pairs will be there, right? In the A cross A. Now, I am defining a relation which contains ordered pair AB such that A plus B is less than 100, where A and B both belong to set A. Okay. So, what do you think? What will this set have? This relation has? This relation will have all the elements because 1 plus 2 is less than 100. 2 plus 3 less than 100. 2 plus 4 less than 100. 4 plus 1 less than 100. 1 plus 3 less than 100. Every combination that you take any combination, it is obviously always less than 100. That is why my relation will contain all the elements and my relation will be called as universal relation. A relation that has all the elements of the Cartesian product. Understood or not? So, if your relation is equal to the Cartesian product, that means it has all the elements of the Cartesian product, then your relation is called as universal relation. Simple. Now, similarly, third type of trivial relation is identity relation. Every Cartesian product has identity relation. What it says? It says that the relation should contain only the ordered pairs A comma A. That means every element should relate to itself only. Can you think of an example? Well, the simple example will be, suppose I have set A 1, 2, 3, 4. Okay, I am defining a relation which is a subset of the Cartesian product A cross A. Relation is defined as ordered pair AB such that A minus B is equal to 0. Now you think, when will A minus B will be 0? A minus B will be 0 when we take 1, 1, because 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0, 4 minus 4 is 0. Any other element Can you subtract and get 0? No, it's not possible. Only 1, 1, 2, 2, 3, 3, 4, 4. Only these ordered pairs are possible because 1 minus 1, 0. 2 minus 2, 0. 3 minus 3, 0. 4 minus 4, 0. So such a relation that has only A comma A ordered pairs. A comma A means same elements in the ordered pair. Such a relation is called as identity relation. Got it? Hi, yellow man, welcome back. Understood what is identity relation? Clear to everybody? So, empty relation, universal relation, they are called as trivial relation. Why are they trivial? Because every Cartesian product definitely has empty relation and universal relation, right? Because every Cartesian product will definitely have, can be defined, like a relation can be defined which has nothing, and a relation can be defined which has everything. Of course, right? Okay, so these are basically the trivial relations. Now coming to our main relations which form together equivalence relation. Okay, so now let's learn about reflexive, symmetric and transitive relation. Okay, oh, before that we have an example. Let's quickly solve this question. For a set A representing the boys in a school, a relation P exists such that P says AB ordered pair, A is the sister of B, and another relation Q says AB ordered pair, the difference between the height of two students is less than 3 meter. Find the type of relation in each of the given cases. Okay, see, the question is saying set A has only boys in the school. Okay. Now relation P says that A is sister of B. Is it possible, kids? Is it possible that only boys school has a sister and a brother? Is it possible that inside an only boys school there is a sister and a brother or a sister and a sister? Not possible. It is a boys school. So how A will be sister of B? A can be brother of B only, right? It cannot be sister of B. So relation P will be empty relation. It is an empty relation because it will have nothing. How can it has anything? Because there is no girl, so how can it be a sister, right? Similarly, relation Q is saying difference between height of two students is less than 3 meter. So relation Q says that A minus B height is less than 3 meter. Now obviously, according to all the humans that we have, difference between the height is always less than 3 meter. School students cannot have height like 1 meter of height. It is not possible. So, every student height will be less than 3 meter only. Definitely less than 1 meter also. So, basically relation Q is what? It is universal relation. It is universal relation. Understood? Okay. Moving on to the main types of relations that we have to study. First is reflexive, symmetric and transitive relation. Okay. Now what is reflexive relation? Again, a relation in a non-empty set A is said to be reflexive if A comma A exists for all A belonging to set A. You will say, ma'am, this is identity relation, na? Same to same. Identity relation was also saying A comma A. This is also saying A comma A. What is the difference? Well, there is a difference. Example, there is a relation having ordered pair 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 3, 2 comma 1 and that's it. Okay. Now, is this relation reflexive? Yes. it is reflexive. Why it is reflexive? Because for a set A having 1, 2, 3, it is having 1, 1, 2, 2, 3, 3. All the A comma A elements are present. Apart from A comma A elements, there are some extra elements, but that is fine. We don't need to worry about the extra elements. We just need to check it has 1, 1, 2, 2, 3, 3 or not. If it is having 1, 1, 2, 2, 3, 3, it is reflexive. Understood or not? Tell me. Are you guys understanding what is reflexive relation? So suppose you have a set A and the set A has 1, 2, 3, 3 elements. Then if I define a relation in which I have ordered pairs 1, 1, 2, 2, 3, 3 and there are some extra elements 1, 3 and 2, 1 also, it is fine if they are there. Can I still call it reflexive? Yes, it will still be called as reflexive because it has all the A comma A elements. Clear? Give me a thumbs up if you are understanding it. Okay, moving on. Let's do some questions so that you understand better. Show that the relation R in the set A, where set A is defined as integers from 0 to 12. The relation is defined as A comma B ordered pair such that modulus of A minus B is a multiple of 4. Show that it is reflexive. Now, for this function to be reflexive, for this relation to be reflexive, so we will write for R to be reflexive, A comma A should belong to the relation, right? All the A comma A ordered pair should belong to the relation. This implies that, now what is my relation? My relation is saying A minus B should be a multiple of 4. So this implies that A minus A should be multiple of 4. What is A minus A? Can anyone tell me? What is A minus A? Tell me. What is A minus A? Anyone? What is A minus A? Listen. Are you guys listening? What is A minus A? 0. So, A minus A is 0. So, 0 is a multiple of 4, yes or no? Who will tell? 0 is a multiple of 4, yes or no? Just guess. Just take a guess, man. Tell me. It is a multiple of 4 or not? It is a multiple of 4. 0 is a sorry. 0 is a multiple of every number. 4 into 0 is 0. 5 into 0 is 0. 0 is a multiple of every number. So 0 is a multiple of 4. Yes. So A minus A is a multiple of 4. Hence proved. Therefore, the relation is reflexive. Now you understood. For the relation to be reflexive, A comma A should belong to the relation. A comma A means A minus A should be a multiple of 4. 0 is a multiple of 4. Yes, that means A minus A is a multiple of 4. Yes, that means R is reflexive. Yes. So my answer is relation is reflexive. Okay, moving on. Next question. Let L be the set of the lines in a plane and defining a relation R such that for two lines L1 and L2, L1 is perpendicular to L2. Show that the relation is not reflexive. Show that the relation is not reflexive. Now think, why is it not reflexive? Why? Simple. For R to be reflexive, for a relation to be reflexive, L comma L should belong to the relation. Okay. Now, L comma, this implies that line L should be perpendicular to line L. Now you guys tell me, can a line be perpendicular to itself? Can one line be perpendicular to itself? Suppose I am a line. Can I be perpendicular to myself? Is it possible? Line L is perpendicular to line L. Is it possible? No, not possible. Not possible. A line cannot be perpendicular to itself. I cannot be perpendicular to myself. How can I be perpendicular to myself? How can I make an angle of 90 degree with myself? It is not possible. A line cannot be perpendicular to itself. Therefore, R is not reflexive. It is not a reflexive relation. Understood? Moving on. Symmetric relations. What is symmetry? Have you guys heard of the term symmetry? In class 8, in class 7, there was a chapter, symmetry between the objects. Do you guys remember that chapter? Symmetry between the objects. What is symmetry? Symmetry. It basically denotes one body divided into half-half. So if identical parts are there, same to same, then they are symmetrical. Symmetrical, right? So similarly, inside a relation, if there is an element, if there is a ordered pair AB belonging to the relation, then BA should also belong to the relation. That means what? If I have a relation R such that it contains 1, 2, it should also contain 2, 1. Okay. If I have a relation R having 3, 4, it should also contain 4, 3. If it is having 1, 5, it should also contain 5, 1. Then only it will be symmetrical. Okay. So, for every AB, there must exist BA. So, if 1, 2 is there, 2, 1 should be there. If 3, 4 is there, 4, 3 should be there. If 1, 5 is there, 5, 1 should be there. Then it is called as symmetric relation. Understood? Let's do an example. Show that the relation R in the set of integers given by ordered pair AB, where the relation is 2 divides A minus B. Is it a symmetric relationship? Let's check. If AB belongs to relation, this implies that A minus B is divisible by 2. Okay. If A minus B is divisible by 2, B minus A will be divisible by 2. Yes or no? Yes or no? Think of an example. Think of an example. 6 minus 4 is divisible by 2. Yes. 4 minus 6 is divisible by 2. Yes, because 2 is divisible by 2 and minus 2 is also divisible by 2. Minus 2 by 2 is minus 1. It is divisible. So, if A minus B is divisible by 2, B minus A is also divisible by 2. This implies that if AB belongs to the relation, BA also belongs to the relation. Therefore, R is symmetric relation. It is a symmetric relation because if 1, 2 is there, 2, 1 is there. 6, 4 is there, 4, 6 is there. 6, 8 is there, 8, 6 is there. Okay. So, for every number AB, where A minus B is divisible by 2, B minus A will be divisible by 2. Therefore, it is symmetric relation. Okay. Next question. Show that relation R defined by AB where A is less than equal to B is a not symmetric relation. Simple. If 2 is less than 3, It implies that 3 is less than 2. Yes or no? Yes or no? Tell me quickly. If A is less than B, this implies that B is less than A. True or false? Come on everyone. True or false? If A is less than B, AB belongs to the relation. Then it implies that B is less than A. True or false? Tell me. Yes or no? No. Again, this is false. It's not possible. It's not possible. It's not possible. Therefore, R is not symmetric. It is not a symmetric relation. Okay? It's not a symmetric relation. Understood? Coming to our last relation, that is transitive relation. Transitive says that if AB belongs to relation and BC belongs to relation, then AC should also belong to the relation. That means what? Suppose I have a relation where 1, 2 belongs to the relation and 2, 3 belongs to the relation, then 1, 2, 2, 3, then 1, 3 should belong to the relation. Then it is called transitive relation. Clear? What is transitive relation? Clear to everybody? Okay, let's do some question. Let L be the set of lines in a plane where R is defined as L1 is perpendicular to L2. Show that it is not transitive. Why not transitive? Very simple. If L1 is perpendicular to L2, if and L2 is perpendicular to L3. Let's imagine this with a diagram. Okay. So I am saying that there is a line L1. It is perpendicular to L2. L2 is perpendicular to L3. So can you say that L1 is perpendicular to L3? Yes or no? Yes or no? Come on, answer. Yes or no? Will L1 be perpendicular to L3? Will L1 be perpendicular to L3? Think. I have drawn the diagram. No. If L1 is perpendicular to L2 and L2 is perpendicular to L3, L1 will not be perpendicular to L3. L1 will be parallel to L3. Okay. So therefore it is not transitive. It is not transitive. L1, L2 belongs to relation, L2, L3 belongs to the relation, but L1, L3 does not belong to the relation. Why? Because they are not perpendicular. So they do not belong to the relation. It is not a transitive relation. Understood? Okay. Now last is equivalence relation. What is equivalence relation? Simple. If my relation is reflexive, symmetric and transitive, then my relation is equivalence relation. Okay, that's it. If my relation is reflexive and symmetric and transitive, then I call it as an equivalence relation. For example, suppose my relation looks like this. 1, 1, 2, 2, 3, 3. Okay, is it reflexive? Is it reflexive? For a set A having elements 1, 2, 3. Is it reflexive? Yes. Is it symmetric? Yes. Because for 1, 1, 1, 1 should be there. For 2, 2, 2, 2 should be there. For 3, 3, 3, 3 should be there. It is symmetric. Is it transitive? Is it transitive? Yes. How it is transitive? Because if AB belongs to the relation and BC belongs to the relation, then AC should belong to the relation. Now there is no AB, there is no BC, so no need to worry about AC also. So it is a transitive relation and therefore this relation is an equivalence relation. Let's have a look at a real life example. Okay. Suppose my relation R is defined as T1, T2 ordered pair, where T1 is congruent to T2. Do you all remember congruent triangles? Congruent corresponding parts of congruent triangle, SSS criteria, SAS criteria, RHS criteria. Do you remember congruency? Congruency means same triangle, right? Now, you tell me, for R to be reflexive, to prove that it is reflexive relation, what you have to do? To prove that it is for my relation R to be reflexive, T1 comma T1 should belong to the relation. This implies that T1 should be congruent to T1. Now you tell me, can a triangle be congruent to itself? Yes. Every triangle is similar to itself. I am similar to myself. This bottle is similar to itself. So yes, every triangle is congruent to itself, na? Every triangle is congruent to itself. Therefore, R is reflexive. Right? Next, what about symmetry? For my relation to be symmetric, okay, if T1 comma T2 belongs to the relation, T2 comma T1 should also belong to the relation. Now you tell me, this implies that if T1 is congruent to T2, T2 should also be congruent to T1. Is it possible? Yes. If this triangle is congruent to this triangle, then obviously this triangle will be congruent to this triangle. Now both are same. That is why they are congruent. So if A is congruent to B, B will be congruent to A because they are same triangle, similar looking triangle. So therefore R is symmetric also. Similarly, again, for my relation to be transitive, what I have to prove? For my relation to be transitive, if T1, T2 belongs to the relation and T2, T3 belongs to the relation, then T1, T3 should also belong to the relation. Now, if T1 is congruent to T2 and T2 is congruent to T3, this implies that T3 is congruent to T1. This implies that T1 comma T3 belongs to the relation. Hence proved my relation is transitive. Therefore, R is an equivalence relation. Why it is an equivalence relation? Because it is reflexive, symmetric and transitive also. Understood everybody? Have you guys understand the concept of reflexive, symmetric and transitive relation? Okay. If yes, then I'll give you a homework question also and you have to answer that in the comment section. Okay. Let us practice one more question. Check whether the relation X R Y, where Y is divisible by X, is an equivalence relation or not. Let's check. For my relation to be reflexive, for my relation to be reflexive, what should happen? X comma X should belong to the relation. This implies that X is divisible by itself. Y divisible by X, that means X is divisible by X because A comma A, X comma X should belong to the relation, then only it will be a reflexive relation. So X is divisible by X, yes, it is possible. Therefore, R is reflexive. Yeah, it is reflexive. Okay. Similarly, I want to prove it is equivalent. So I will prove reflexive also. Now, sorry, symmetric also. For R to be symmetric, what should happen? For it to be symmetric, if x comma y belongs to R, then y comma x should also belong to the relation. How is it possible? X is divisible by y. This implies that y is divisible by x. Is it true? Is it false? It is true or false? If 4 is divisible by 2, then is 2 also divisible by 4? No. 2 is not divisible by 4. So if x is divisible by y is not divisible by x. Therefore, R is not symmetric. It is not symmetric. And since it is not symmetric, it is not equivalence relation. It is not symmetric, so not equivalence relation. Understood? For equivalence relation, it should be reflexive, it should be symmetric, it should be transitive. Alright guys, so here is the homework question for all of you. Solve this question and tell me the answer in the comment section. Okay, I will see who all have solved it correctly. You have to tell this relation is reflexive or symmetric or transitive. Think about it and let me know in the comment section. Alright? Okay? Sorry. Okay, so that's all for the day guys. Today we have completed the different types of relations that we have. Now let's summarize. What did we learn today? So we have learned about the trivial relations, the different types of relations. Empty relation, which has nothing. Universal relation, which has everything. An identity relation, which has only a comma a elements. Okay. Similarly, we have learnt about equivalence relation. What is equivalence relation? A relation that is reflexive, symmetric and transitive. What is reflexive? For all A belonging to A comma A ordered pair should belong to the set. For all A comma B belonging to the relation, B comma A should also belong to the relation. Transitive says that if AB belongs to the relation, BA belongs to the BC belongs to the relation, then AC should also belong to the relation. So if all three are satisfied, then it is an equivalence relation. Alright guys, so this is what we have learned till now. We have completed all these topics. In the next lecture on Monday, we will learn about the different types of functions. Now, different types of functions is a very important topic. Questions are asked from that topic a lot of time. Okay, so do attend that session. Also, if you want notes of this lecture, you know you have to join our Telegram channel. Scan this code or simply search for Vedantu Malayalam on the Telegram app. Just download it and search for our channel. Okay, so guys, if you enjoyed today's lecture, bring your friends also, na? Bring all your friends. Ask them to subscribe and join our channel. And if you enjoyed today's lecture, don't forget to hit the like button and we will have much more fun sessions every day. Alright, thank you so much for joining. Leave a comment. Do leave a comment and tell me, how did you find today's lecture? Did you enjoy today's lecture or not? And what are the other things we can bring for you guys? And don't forget to answer the homework question. Okay. Thank you so much everybody. See you on Monday 8 p.m. with lecture number 3. Bye-bye. Take care. Bye guys.